Hello, and welcome back. This is James Camp, your friendly computer science instructor from Lee College in Baytown, Texas. And I'm here to talk today about pointers in C and C++. So we've already established that there are memory boxes, okay, and a memory box gets a variable name like foo, and then it gets a contents like 1, 2, 3. Okay. And then there's another memory box called bar over here. And it has the contents 3, 4, 5. Okay. So far, so good. We can say in our code, foo equals 42, and foo will be erased and written over with 42. Okay, so far, so good. We can write code that says bar equals foo, and what happens? Does bar become the same as foo? No. Bar gets erased and written over with the same value. Got a dead spot on my screen there. The same value as foo, the same 42. Okay, but they're still independent variables. But in C and C++, there's the concept of something called a pointer. Foo does not only have a foo is a memory box, and that memory box, every memory box has a unique address, like 1, 2, A, 4. And maybe this one is 1, 2, A, 6. What's the A from? Memory addresses are typically written in hexadecimal, which is a way of representing 16. It's base 16, so it's a way of representing base 2 numbers that get really, really big, like memory addresses. Okay. Now, what's cool about what a pointer does, let's say I create a new pointer. And the syntax for that in C++, I call it FP. I would write int star FP for foo pointer. Okay, so that creates a pointer called FP, and I say it equals at's a different language, sorry, equals ampersand foo. So the value of FP is not 42, it's 1, 2, A, 4. Okay? And what that means is that FP points to foo. And I could come over here and find another memory box and create another pointer called BP for bar pointer, okay, and give it the value 1, 2, A, 6, okay, and now it's going to point to bar. So why would I care about this? Well, I wouldn't really want to have one pointer for each variable that I already have. That would be kind of silly. But let's say I had a whole lot of bank accounts. One of them belongs to Juan, and the other one belongs to Barb. Okay. And I have one set of code that knows how to read and set bank accounts. Well, I might create a memory box called account pointer. Yeah. There. And I might write the code account pointer equals ampersand 1. Okay. So at this point, account pointer points to 1. And then I might say, which means it gets value 1 to a 4. Then I might set the value of star account pointer to 100. Or maybe I say plus equals 100 because Juan just got paid $100. Well, that will look at whatever account pointer is pointing to and add 100 to it. Yay, Juan now has $142. Now, I say account pointer equals ampersand Barb. Why can't I write today? Ampersand Barb. So now, this account pointer gets value 1 to a 6, and it's pointing to Barb. Okay. Now what do I want to do with Barb? Well, Barb owes me $20 for a pizza I bought for her last week, so star account pointer minus equals 20. So that comes over here and takes this 42 and turns it into 22. Okay. So I can write a banking program that only needs to know about one account, which is this account pointer, and I can have it point to any other account I want to at any given time. Juan or Barb or Joe Smith or anybody else's. Okay. That's just one use of pointers. There are numerous other things that you can use with pointers, and we'll use pointers when we talk about inheritance and polymorphism in object-oriented programming in C++, because that's really the only way you can get polymorphism to work in C++. But for now, we just need to know that there are these things called pointers. They hold memory locations, and they point to other variables that hold actual values. Okay. You'll learn much more about pointers in the rest of today's lecture, so go get to it. And as usual, good luck and happy programming.